Speed and safety. These are two words that might sound like opposites, but in modern application development, they actually go hand in hand. Modern software teams are very focused on speed, right? Getting those features fast and those updates fast to the users. But they also know that that speed almost becomes irrelevant if they ship insecure software. So this is why they put such an emphasis on embedding security from the early stages of the software development process. This proactive approach allows them to not only enforce security more consistently, but also finding those issues faster, responding to them faster, and at the same time, avoiding to waste engineering time on insecure components that they would have to spend more engineering time to fix. Well, my name is Gerardo Estava, and today, with the help of a virtual whiteboard, we're going to cover what it takes to get security right in modern application development. By the end of the session, you should go away with some practice, principles, and recommendations so that you can improve the speed at which you create software with security in mind. So let's do it. I want to start by telling you about a retailer. This is a development team that I met with a couple of years ago. At the time, they were building containerized applications, and they seemed proud of the work they had recently done to automate their software release process. So these guys were no longer initiating builds manually, no longer manual editing of configuration files. So at least all of their active and important projects had CI/CD pipelines following a process like this, with automation in between each step. At the time, they also told me they were taking security more seriously, and they had hired this security team for the purpose of doing just that, taking security more seriously. Now, the team had been working on a project. This was a long project. So we're talking about a bit over a year, so several months, working towards this launch that was a new experience and loyalty platform for their customers. It was at the top of the priorities for the CIO. And despite being aligned and despite being well-funded, they missed the deadline. So why did they miss the deadline? So one of the reasons I would argue is that, and I discovered this while talking to them, is that this security team acted as sort of last gatekeepers before deploying the code to production. And so this was not great, not ideal. So to paint a picture how bad it was, we're talking about hundreds of critical vulnerabilities before launch. We're talking about unpatched images, all libraries, even some hard-coded credentials in their code. Basically enough material to give these guys, or make these guys reconsider their career choice. And so there was no way they were going to launch something so insecure. And the fallout was intense and immediate. CEO gets involved, marketing had to pull the plug on a massive campaign they had not only prepared, but paid for. And there was plenty of finger pointing. So the security guys blaming developers for not enforcing dependency management and other things, and the developers blaming the security guys for having unreasonably high standards and not understanding what it takes to ship software fast. I hope that this example doesn't sound too familiar to your working environments. And so I want to tell you what they did to start trying to remediate this. And so they started bolting on security in their application. And so in order to do that, I want to show you what their architecture looked like. So this is a simplified version of their architecture. As you can see, I've organized it so that there are 3 layers. So you have one layer here that is a content delivery and the entry point of those APIs. You have another layer here with some of those microservices, some hosted as ECS services and others in AWS Lambda functions. They had a 3rd layer with data store. So they had I can't remember if it was a React app or an AngularJS app, but they had a single web page app stored in S3 that's been delivered to users via CloudFront. And some of the microservices, they use a combination of MySQL databases, and others use key value stores in DynamoDB. And so they started bolting on security to this thing. One of the first things they did is they used a service called IAM Access Analyzer. I'm just going to keep it as AA. This is a service that does a few things Well, the first thing it does is it highlights services that are shared across organizations. And so very typically, you may share an S3 bucket with another organization, and this is the kind of service that highlights that for you. The second thing the service does is it analyzes IAM policies and it compares that or benchmarks those against best practices. So it gives you ideas on how to improve your IAM policies. It also finds unused and unnecessary roles and policies, some of those that tend to accumulate over time in AWS accounts. And the smartest feature of this service that wasn't available by the time the retailer was using it is it checks for activity. So it checks whether you're actually using the policies in the way that you've described them. And if not, if you've been over-permissive with the policies, it suggests scope down permissions for you to enforce least privilege access. So very useful service. The retailer uses it just to analyze the best practice of the policies and sort of like cut down those over-permissive policies. So that's one of the things they did. They also took those hard-coded credentials that I mentioned out from their code into a service called AWS Secrets Manager. Oof, my writing is terrible when I'm on stage. So this is a service that it does a few things. So it stores the credentials securely for you. And I think the most powerful thing is that it gives you as a developer an SDK. And so you use your SDK in your code. And so you can create new secrets, or you can retrieve the secrets securely without worrying about encryption and decryption, which is what you would do if you don't have a service like this. And it also further helps improve security by rotating credentials for you without disrupting the application in some of those native services like RDS and Redshift. So a great service to use. But the big line item for this retailer at the time were the long list of vulnerabilities. So for some of those, they implemented a service here at the front, which is AWS WAF, which is a service that allows you to create rules to filter out those common web exploits like SQL injections and cross-site scripting. But for the bulk of the vulnerabilities, they needed something more, and so they use a combination of Amazon Inspector and one of those cloud-native application protection platforms. Now, the problem is that this was painful and very hard. I want to paint a picture of how it was. When you have a handful of vulnerabilities, yes, you can put some engineering cycles toward mitigating them. But when you have too many, think about this. One developer takes one vulnerability, redevelops that component, and then that in turn affects the integration with another component, and so you also have to redevelop that component. So you've now redeveloped two components, and then you pick up on a second vulnerability that affects the same components that you've already redeveloped. It was a horrible tangle and frustrating tangle of vulnerabilities. So you can only bolt on security so much. And so don't get me wrong, bolting on security does work. It's just that the pain, frustration, and time that you need to invest is a lot more than you would have if you had taken security consider from the beginning. And this is best reminded from a quote from our CTO, which I've hidden right here, that goes, "The best security is built in, not bolted on." What it means is that when you consider security from the beginning, speed is faster and everything is more secure. And so what you want is you want to build security into your systems from design. And you can do that, and one of the mechanisms you can do this with is with testing. Your testing phase doesn't have to be all about integration testing and load testing. You can have security testing embedded in it. So let's talk about testing a little bit. So with security testing, or with any kind of testing for that purpose, you want to have an exact replica of your application, or something that looks almost identical to what is going to happen in production. And the reason you want this is because you want the tests in the testing phase to replicate or mimic what would actually happen in production. And so what can you do in this testing phase in terms of security? This is the right place to do dynamic application security testing, or DAST. The key word here is dynamic. And the reason is the right place to do this is because you have a fully deployed version of your application. And Dust what it does is like it mimics what an attacker would do by trying to get into the application or breach into the application from the outside in. So this is the right place to do that, as long as with production. This is also a place where you can check for vulnerabilities with tools like Amazon Inspector that I've mentioned before. This is the logo, because now you have running components, and a tool like Inspector can check on your running Lambda functions and your running instances, even within the software packages that they use. And so it can find vulnerabilities for you. During testing phase, you can also do penetration testing, pen test, which is like hiring a friendly thief to test your home security system and tell you whether you need better locks and better cameras. So it's getting someone else's eyes in the security of your application apart from your own probably biased eyes. So the problem with this retailer is that they started implementing some of these things as an afterthought. And so by relegating security to the last stages of the testing cycle, they basically had no time to remediate that long list of vulnerabilities, and it was just too complex to do. So what you want to do, and another principle in modern application development, is you want to shift left those security controls in order to detect things early. And so, what happens before a testing environment, and can you test for security there? Well, what happens before is usually a build phase. In a build phase is generally when you are doing things like compilation of code, so you're compiling code, where you're building all those artifacts for deployment, where you are packaging your infrastructure as code templates. And because you're doing these things there, it allows you to do another type of security testing, which is called SAST, or static application security testing, that differs from dynamic in that you're testing individual components. So you can test for those different artifacts that you have there. In particular, you could test, for example, on the container images. And I do remember at the time of the crisis of that retailer that one of the security inclined engineers that had taken a stab at automating security checks, all this person had done was running a container scanning tool and then deciding to fail the pipeline or not, depending on the outcome of that scan. And when the security team saw that, they went, this is exactly what we need. And so that's how in this retailer, automated security checks were slowly rolled out into most of their projects. Now, in the build stage, it's where it gets very interesting for infrastructure as code, because you can use a tool called, or you can use a practice called using a policy validation tool. I'm just going to go policy validation tool, that checks for the security configuration of your infrastructure before deploying any infrastructure. I'm going to say that again. You can check for the security configuration of your infrastructure before deploying any infrastructure. Very powerful. So a tool that acts as a policy validation tool for infrastructure as code that you can use is CloudFormation Guard. So this is a CLI that lets you do two things. It lets you express policy as code, so you define what your security posture is going to be. It comes with several controls by default. You can disable any rule you don't like. You can bring your own rule if you like to write a couple of rules. You express the policy as code. And then during build time, you can run a command to validate a CLI command to validate your template against that policy. And you can choose to fail the build or not. So you are shifting left those controls for checking the configuration of your infrastructure before deploying any infrastructure. It's very powerful. So how can we take this further? Maybe further left. So what happens before build, and can you test for security there? So what happens before build is that generally you have just chucked some code into a repository. And of course you can test for security here. So once you have your code in a repo, you can do things like peer reviews. This is just a fancy term for having another human looking at your code and evaluating if you're using good security practices. This is also a place where you can further expand your SAST testing. In this case, you can use tools that specifically look into your code. And so it can find vulnerabilities in your code or log injections or the correct use of AWS SDKs and APIs. That's what these sort of tools do. Some of the SaaS tools also offer a functionality that I think is very powerful called SCA, and it stands for Software Composition Analysis, which is sort of like an X-ray machine that scans all your code, identified all the different components and libraries that you've used to build your project, and it tells you what are the security vulnerabilities of all those individual components. So it helps you remediate that. Now, one of the tools that is a SaaS tool for your code that also offers SCA is Amazon CodeGuru Security, specifically the security part of CodeGuru. This is a tool that uses machine learning to analyze your code, find vulnerabilities, also find deviations from policies that you create. And it gives you, highlights a report, and explains what the risks are, and it gives you even code level fixes to fix the issues that it finds. So a very powerful tool. And unfortunately, this is as left as you can test for any security in your software creation process, isn't it? Well, if you thought this wasn't going to be a Gen AI session, it is. So we are already seeing in the era of Gen AI, some of our customers are using tools like Amazon Code Whisperer and Amazon Cube for not only increasing the speed at which they release software, but also improve the security. So instead of telling you about it, I'm going to take a bit of a risk here, and I'm going to show you in a demo. Can we please switch to my laptop? Great. Okay, so let's say that you're using VS Code for building those components in your application. After you've installed the AWS Toolkit, you're going to get these two icons here. So this is the Toolkit, and this is the Amazon Q preview. And so Code Whisperer is a fully featured AI code generation tool. So you can imagine how generating code for you helps you with the speed side of things. Unfortunately, this is a security session, so I'm not going to be able to get into that. If you want to learn more, you should go to another session. But Code Whisperer offers a security feature that lets you scan for vulnerabilities here. So running security scan. So what it's doing right now is I'm running the security scan on these two files here. So let me show you what I've got. So these are just two simple snippets of code, one with a SQL injection vulnerability. This is an interaction with the Django DB. And the second one is even simpler than that. It's you're interacting with a website, with a URL, public URL, and you're not verifying the TLS certificate. And so these are the sort of things that, Code Whisperer finds. So you can see that it found two with one that found twice, live demos. So let's see what they are. So this first one is a SQL injection vulnerability. So you can go here and it tells you what it is. It seems that we're constructing SQL queries using formatted strings, and that's not a good thing. Instead, we should be using parameterized queries. And it gives me this beautiful, I think it's beautiful because it makes life so simple, apply fix button that you just clicks, and it modifies the code for you, fixing that vulnerability. Let's go to the second one. The second one is this one. So let's see what it is about. Improper certificate validation, fair enough. You're not checking a TLS certificate that you're interacting with. And for this one in particular, it also gives me the apply fix. So not all the recommendations by Code Whisperer offer that magic button. I'm going to show you in a second. But while it runs the scan on this new file, and hopefully it mitigates those findings, I want to recap what just happened. Here you have a tool right in your IDE that checks for security in your code, that explains the risk for you, and that it also gives you sometimes the magic button to apply a fix into it. Super powerful. So you can see how now my first file doesn't have any more vulnerabilities, but I want to show you something a little bit more nuanced. So here we have, this is a Lambda function that is interacting with a MySQL database. So let's look at that vulnerability. So this is hard-coded credentials. So hard-coded credentials doesn't have just some code to fix it. You're going to have to interact or handle those credentials in some other way. And it tells us that possible remediations are using environment variables or using a secrets manager. So let's say that you're not sure about this, you've never heard about it, and you want to do some research. So you can go right here to Amazon Q, which is an AI companion that's an expert on AWS and also a coding expert, and you can just ask it for it. So, environment variables versus secrets manager. And so, right in your IDE, you can get some research done. And you can see that it's going to construct an answer, usually a comprehensive answer that I'm not going to have time to read in its entirety. But if we jump to the conclusion, you can see that it generally recommends Secrets Manager for reasons. Between us, with environment variables, you have to encrypt and decrypt those secrets yourself. With Secrets Manager, it's all done for you. It's one of those sort of no-brainer services. So now you have two ways of solving this. You can either ask Amazon Q to write some code for you, or look at this. So I can just highlight some code, I can right-click, and then send to Q, and then fix, and see what happens. So maybe it's going to pick up, maybe it's going to pick up that these are some hard-coded credentials, and it's going to give us a way to fixing those credentials. So you can see that it actually generated some code here. I can actually ask it to give it to me maybe on a better format. So write some Python to define a variable so that I know that integrates well with the way I'm using variables in my code to retrieve it from Secrets Manager. So you can see here that it generated some code and that it's explaining what the code does. You can just copy and paste. And with this sort of thing, you're going to have to check that it actually does what it intends to do. But how powerful this is. Now you have tools right in your IDE that allows you to do the research, that allows you to do code generation, that detect security issues for you, and that sometimes give you code level fixes for those security issues. Super powerful, you should consider using them. And so let's move back to my slides, because I wanna, not slides, sorry, just I'm used to slides, to my whiteboard. I want to tell you how that story ends for that developer. And so, after months of work and a lot of work in bolting security into this application and a lot of work on fixing those vulnerabilities, they did manage to get the confidence to launch the product. It was months later, it happened, and fortunately they did launch. But I want to recap, what are those two or three sort of root causes, cultural, in terms of culture and practices, that got them into this issue. The first one is, you saw how they were bolting on security as an afterthought, and that's not a good thing. You've seen how hard it is to do it afterwards. It does work, but it just makes things longer in time and very frustrating. Counterintuitively, it slows you down. You think you're not considering security, but it's going to slow you down because you're going to have to fix it anyway later, and that takes more time. Same with light security testing, not a great practice. You can almost see how these two practices, they almost make your code insecure by default. So this is usually a symptom of organizational cultures that see security as the enemy, you know, and that's certainly not healthy, certainly not seen that we see something that we don't see in modern application development. In those cultures, you see the behavior of scrambling to fix problems only after they occur. So, which brings me to all of this is very, very tied to culture. The behavior of seeing security as someone else's problem, it's an old school mental model that is certainly not seen in modern application development. So, fortunately, this retailer, things have changed. So these guys are building automated pipelines. They are checking for security early. Everything's automated. So they've come a long way. And in hindsight, I do think that this was a great event for them for two reasons. One is that there was no victim here. So this is not a story of a massive hack and customer trust and the media. This is a story of just a development team that didn't get to launch when they wanted. But This issue gave them enough reasons for them to change the way that they operated, and this is what got them to where they are today. So let's close this session, and I'm going to give you some things to go away with. So this is a summary of all the mechanisms that we talked about and how to embed security in your software creation pipeline. Some of the principles that we talked about: you want to apply security at all layers, but you want to do it by design, not as an afterthought. You want to shift security left in an automated way, even as left as in your IDE, because now you have the tools for it. And you want to change the way, or modern application teams change the way they approach security from the culture perspective, by making security the responsibility of every single builder, by embedding security teams or security advocates within those teams to help them ship secure software fast. The benefit of doing this is you're going to enforce security more consistently, you're going to find issues early, you're going to respond to some security issues early, and the counterintuitive part, you're going to save engineering cycles that you would otherwise spend fixing those issues later, and that takes longer, more time, more frustration, so you get to ship software faster. Your homework for today is try to find some easy wins, some areas where you can embed some things that you can try in your software creation process. You could try Amazon Code Whisperer and Amazon Q in your IDE for research, code generation, security checks, and remediation as well. You can try CloudFormation Guard for shifting left and analyzing the security configuration of your infrastructure before deploying any infrastructure, or you can use Amazon Inspector for automated vulnerability management. If you want to know more, please go to skillbuilder.aws, and please don't forget to leave your feedback. So the QR codes on the left are for downloading the app. The one on the right is for you to specifically rate this session and give me a comment. I personally read every comment that you give me. Thank you very much for being here. I hope that you enjoy the rest of AWS Summit and that you get to ship software securely and fast. Thank you.